Let's take a look at this series parallel circuit. This circuit has 6 resistors, R1 on the main loop, a parallel arrangement with R2 and 3, and then another parallel arrangement with R4, 5, and 6. Now this question is asking us to calculate the total resistance. Alright, so now you want to take the circuit apart and do individual parts before getting to the final calculations. So I'm going to remove the parallel arrangement with R2 and 3 and do it separately. Now for calculating the equivalent resistance of two resistors in parallel, we will use a product over sum method, and that is R2 times R3 divided by R2 plus R3. And so now the values are 4 times 4 divided by 4 plus 4 is equal to 16 divided by 8. So R23, which is what we named the resistor, is equal to 2 ohms. So the equivalent resistance of R23 is 2 ohms. We're going to insert that in the circuit as one resistance, naming the resistor R23. Now that we've completed the first parallel arrangement, let's take a look at the parallel arrangement with R4, 5, and 6. Let's name this resistance, equivalent resistance, R4, 5, 6. So we'll have 1 over R4, 5, 6 is equal to 1 over R4, 1 over R5, plus 1 over R6. Which is equal to 1 over 8 plus 1 over 3 plus 1 over 12. At this point, you will go ahead and find the LCM, which is the lowest common multiple for 8, 3, and 12. And in this case, it is 24. And so you will divide 24 by each of these denominators. So 8 into 24 goes 3 times. 3 times 1 is 3, plus 3 into 24 goes 8 times. 8 times 1 is 8. Then 12 into 24 goes 2 times. 2 times 1 is 2. Alright, so at this point you want to add these three numbers. 3 plus 8 plus 2, that is equal to 13. 13 divided by 24. So now you want to find the inverse of R456. So you will flip the fraction and say 24 divided by 13 is equal to 1.85 ohms. Remember, you flip the fraction or rotate the fraction to remove the inverse or remove the 1 from over R456. Now I'm redrawing R456 in the main circuit as a single resistor, having a resistance of 1.8 ohms. At this point, the circuit has become a simple series circuit. Alright, let me go ahead and erase this so we can do the final calculation. Now you already know that for a series circuit, the total resistance is equal to R1 plus R2 plus R3 and whatever number of resistors there are in series. But for this particular one, we use the resistors that are listed. So RT is equal to R1 plus R23 plus R456. This is equal to 2 ohms plus 4 ohms, 2 ohms plus 1.85 ohms. And this is equal to 5.85 ohms. So the overall resistance is equal to 5.85 ohms. Please note that I was supposed to erase that 4 ohms resistance from under R23. Yeah, that was an oversight.